Welcome back, students. In this video we're going to cover Module 10 topics 1 and 2. This is circles, circumference, and measuring angles and arcs. This is of course page 1 of the Module 10 packet. The objective in this lesson, you guys are going to find and apply definitions of radius and diameter to find circumference, and measures in intersecting circles. Let's see, you guys are also going to find measures of angles and arcs in circles. Alright, so go ahead and jump into it here. I'm just going to scooch up. So the bell work, and this is pretty simple stuff. You really shouldn't need me to answer it, but I'll go ahead. So number one, recall. What are the formulas for the circumference of a circle? So circumference can be found by 2 pi times the radius, or pi times the diameter. All right, number 2. If TU is 14 feet, what is the radius of circle Q? So this symbol means circle. So circle Q is this one. TU. So this is the diameter, and it's 14. So the radius is half of the diameter. So the radius is going to be 7. And then number 3, radius of a circle is 3. What is the circumference? So 2 pi r. So circumference is 2 pi times 3. So this is 6 pi, but we're going to just say 6 times pi equals 18.8. And they didn't give us units, so it's just 18.8. Okay. Alright, let's see. Let me write my words in real quick. I'm not going to pause it. Diameter, and let's see, congruent. Okay, congruent. Okay, so excuse me. Let me just scooch this up so we got everything in here. All right, so parts of a circle. A circle is a set of all points in a plane that are the same distance from a given point, missed the line here, called the center of a circle. Sorry, it's a little together there. I'm a math teacher, not an English teacher. The center of the circle below is C, so point C. And it's also going to be circle C. That looks like an eyeball. All right, so a radius of a circle, the plural for that's radii. That's a line segment from the center to a point on the circle. So right here, CF, CE, CD. So CD, CF, CD, CE, and CF are radii of circle C. A chord of a circle is a segment with endpoints on the circle. So remember, the circle is the line. So AB, see, A and B are touching the circle. They're a chord. And DE is also a chord. Notice it's also the diameter. We'll get to that in a second. But AB and DE are chords of circle C. A diameter of a circle is a chord that passes through the center. DE is the diameter of circle C. And I like to say that the diameter is just a special chord that just happens to go through the center point. But just as long as you remember, it is a chord. All right, and all radii, excuse me. Sorry. There we go. All radii of a circle are congruent. And it's because the diameter is composed of 2 radii, so all diameters of a circle are also congruent. So a radius, or a radii, is from the middle to the end. So again, CD, CF, CE, as long as it touches the middle and touches the circle. And of course, that's how we measure the circumference, is that radius or the diameter. So obviously all radii are going to be the same because the center point is equidistant from the circle. All right, let's see here. All right, so number one, identify the name of a circle. So it says name the circle. So notice the center point here is X, so it's circle X. Identify a radius. So we've got XT. We've also got XU and XZ. Well, actually XV. We'll go alphabetically. And XZ, and these are all radii. All right, a chord. So we've got two of those chords, RS, and then TZ. And then TZ is also the diameter. Okay, so TZ is your diameter. And that, of course, is the next thing they ask for. All right. Switching down to the bottom. All right, number two, bottom of page 1. So we got this picture of traffic circles. So traffic circles, also known as roundabouts, are circular roadways that reflow traffic in one direction around an island. So you come in and you go around and you exit where you want. A car enters a traffic circle and is 18 meters from the center of the island. So what they're telling you is that from the car to the middle is 18. Well, that's the radius. Okay? So 18 meters from the center of the island. The car drives around the traffic circle until it gets back to its original position. What is the circumference of the car's path? So what is the circumference, and the radius is 18 meters. And shout out to the band. I hear them in the background as I'm making this video. So if you hear this and tell me you heard the shout out to the band, I'd appreciate it. Maybe even give you extra credit. All right, so we're looking for circumference. Circumference is 2 times pi times the radius. We got a radius, so let's just plug it in. So our circumference is going to be 36 pi, or 2 times 18 times, which is 36, times pi, which gives you 113.09. We're going to round that up. So it's 113.1 meters. Meters because it is circumference, which is distance. If it was area, it would be squared. If it was volume, it would be cubed. I like to mention that because I'm a math teacher. All right, flip around here. We're going to go to page 2. Okay, let's get repositioned here. Too far up. Okay. Okay. All right, page 2. Parts of circles. So as with other figures, parts of circles can be congruent, similar, or share special relationships. So postulate 10.1, I have my highlighter, so I'm using my yellow pencil. All right, so postulate 10.1 says 2 circles are congruent if and only if they have congruent radii. This is example GH is congruent to JK, so circle G is congruent to circle J. So we don't have this drawn here, but so G, and this would be H, and then over here, circle J, this would be K. All right, so if these two are congruent, so the two circles are congruent. And it's because you use the radius to get the circumference, and if the radius is the same, that the rest of the equation is the same, so they would have the same circumference. All right, theorem 10.1, all circles are similar. So, I mean, you know, when we talked about triangles, they had to kind of look the same to be similar. Well, all circles are round, so they're all similar. That's just the only way I know how to tell you. All right, concentric circles. So they're coplanar, so they're on the same plane and they have the same center. So for over here, this would be circle A, and this would be circle A. It's just that this one goes with this circle. I'll just make B green. Oops. Goodness. Pencils. And then AC, oops, be pink. All right, so they're inside the same circle. They have the same center point, so they're actually named the same, but they are two different circles, but they're concentric. Geez. Okay. Scooching down here, kind of hanging off the table. All right. So it says number 3. Maybe we had number 2 and I missed it. Let me scooch my chair a little closer. Okay. All right, so it says the diameter of circle K, I'm just going to say it's yellow, it's 12 units, okay? So this guy, so the diameter is 12, so the yellow there is 6. Remember the radius is half the diameter, so I'm just going to put a 6. That's for this guy, because it's half of 12. All right, let's see. All right, we'll go pink here. So the diameter of circle J is 20. So from E, okay, let's see, from E all the way to the other side. I had to go above so you could see, because that little bit there is E to D is it's going to be yellow because it goes from K to D. All right, so yeah, as a matter of fact, let me write that down. So right here, K to D is going to be, so that's 6. It's half of that, okay? And then JE, I'll write that under here. That's half of that because it's the radius, that's the diameter. All right, so we need to know those two things. All right, let's see, hold on, flip over. Okay. So, they want us to find EK. Let's see, how can I do this? EK is going to be green. I'm going to do that, okay? So we're looking for the green part. So, the first thing we need to do is find out how much this is. Let me find... I want to make this easier with the colors and with the... Hold on. Sorry, other notes there. Goodness, all my pencils. All right, so we're looking for this blue section right here. Hopefully you can see that. The green is what we're looking for. The blue is, yeah, in between here. So we need to find how much much that is, then we can subtract that from this diameter. I'll show you. So KD, yeah, so KD is 6. It's yellow. JE. Oh, they give us JD. Yeah, so actually, yeah, all we have to do is subtract JD, which is JE. Hold on. So JE is 10. JE equals JD plus DE. We need DE because we're going to subtract it from KD over here. Just stay with me. Where is my other color here? We can try to... I feel like these colors are kind of close together, but let's see. So they gave us this, the brown. So we're going to subtract the brown from... It's this red. It messes up, but it should be from here over red. I mean, it goes all the way over, but we don't care about that. So we're subtracting the brown from the red to get the blue, and then we're going to subtract the blue from the yellow to get the green. Probably should have thought ahead on the coloring scheme, but that's all right. So that's why we're saying JE, that's the whole line, equals JD plus DE. So DE is what we're looking for. They gave us JD. JD's 8. DE, and then JE was half of the diameter because it's the radius. All right, so DE is going to be 10 minus 8. These cancel. So DE equals 2. Okay, you guys with me? All right, it's not like I can hear you. Okay, so now over here, KD, that's the whole other one there. So KD equals KE. Well, EK is what we're looking for. So DE plus EK. All right, so DE, well, I'm going to write it over here. DE equals 2. That's what that was, but I want to write it there. So DE equals 2. KD equals 6. See how we're doing this? So we got EK. We're going to subtract 2 from both sides. These cancel. 6 minus 2 is 4. I'm just going to come over here. I'll just write it there, but then I'll write it again here. So EK equals 4. So I did all that, and I know it's a lot, but as I told you guys in class when we went over this, this very similar questions on the test. So kind of, and this is a good question for the EOC as well. Okay, let me write some info under here. There we go. Scratchy throat this evening. All right, so sideways. All right, so measuring angles and arcs. Central angle of a circle is an angle with a vertex at the center of the circle and all sides that are radii. ABC is the central angle of circle B. So down here, we'll just do this. So ABC is the central angle of circle B. Okay, and then also, so a degree is 1/360th of a circular rotation about a point. This leads to the following relationship. Excuse me. Sum of central angles. So the sum of the measures of a central angle of a circle with no interior points in common is 360. Okay, so let me show you. We're going to say that angle 2 here. Actually, let me pause the video. I'm going to try to do some editing as we go. Okay, sorry. So, sum of central angles here. The sum of the measures of central angles of a circle with no interior points in common is 360 degrees. So in this case, none of these angles have any interior points in common. So the measure of angle 1, which is the brown, plus the measure of angle 2, which is the green, plus the measure of angle 3, which is the blue, equals 360. So because the circle is all the way around, it's 360 degrees. So it's like these pieces of the pie or pizza, whatever. But the brown plus the green plus the blue all equal 360 because that's a full circle. Okay, let me scooch down here at the bottom. Explain a couple of things here. Okay, an arc is a part of a circle that is defined by two endpoints. A central angle separates the circle into two arcs with measures related to the measures of the central angle. A minor arc has a measure less than 180. Okay, so that's less than half a circle. You know, if a circle's 360, half of 360 is 180. All right, the measure of the minor arc is equal to the measure of its related central angle. So in this case, the measure of arc PR, so this is the arc, it's showing right here, arc PR is equal to the measure of PQR. So when we look for that, so we'll just keep that in mind. All right, so a major arc has a measure greater than 180. The measure of a major arc is equal to 360 minus, let me just, hang on, 360 minus the measure of the minor arc. Just do this measure of the minor arc with the same endpoint. So in this case, the measure of PSR, so PSR, so it's yellow all the way around, is equal to 360 minus the measure of PR. So we would take the measure of this angle and subtract it from 360, and that would give us the measure of that arc. All right, so a semicircle is an arc that measures exactly 180. So again, half a circle. The endpoints of a semicircle lie on the diameter because the diameter goes straight through the middle. And so in this case, what does that say? R. So RST. I'm just going to do the points because I don't want to get it confusing. So RST is going to be, where did it say? RST is equal to 180. So RST. So this half of the circle. I know we went here, but that was for that other portion. All right, and congruent arcs are arcs in the same, or congruent circles have the same measure. So obviously, if the circles are congruent, the arcs are going to be congruent. We won't deal with a lot of arcs with two different circles. We're going to mainly deal with one, but I'm going to reset. There, reset and pause just a second to situate our... Okay. All right, so page 3, and this will finish up this particular lesson. Topics. All right, so 10.2, in the same circle or in congruent circles, two minor arcs are congruent if and only if their central angles are congruent. So if the arc measure has to do with the central angle, then obviously they have to be congruent. So in this case, if angle 1, that's the blue, is congruent to the angle 2, that's the pink, then FG, that's this blue arc, is congruent with GH, that's the pink arc. So notice the arc is the same as the angle, you know. It's like pieces of a pizza. All right, so arcs in a circle that have exactly one point in common are adjacent arcs. So in circle M over here, HJ, I put that in brown, and JK, that's green, are adjacent arcs. And as with adjacent arcs, you can add the measure of adjacent arcs. So, you know, and adjacent, of course, next to. We've talked about that before. All right, 10.2, arc addition postulate. So the measure of an arc formed by two adjacent arcs is the sum of the measure of the two arcs. So we'll just make this here to here. All right, so xz, that's the whole arc, equals xy, that's the brown, plus yz, that's the green. Okay. All right, so just like angles with the triangle, just remember the circle goes to 360 instead of 180 like the triangle, and you know, just remember these rules as we go. All right, find the value of x. So x is going to be over here, this side of DE. I'm just going to kind of make a little, actually we'll just do this. So we'll say, you know, so x is over here, this much of the pi. All right, so the whole circle is 360. We have 85 minus 40. And what's the box mean? God, I hope you're already saying 90. All right, so 360 minus 90 minus 40 minus 85. Doesn't matter which order you go. It's going to equal 145. So in this case, x equals 145 degrees. And if you add 145 plus 90 plus 40 plus 85, that's the whole circle, which is 360. All right, number 2, find the value of x. So x is right here. Yep. So whole circle's 360. We got 165 here, 145 here. We subtract all three of those, and we get 50. So in this case, x equals 50 degrees. Okay. All right, bottom of page 3. All right, let's see. And what I'm going to do with this, so I'm going to cut the video at number 4. I'm going to let you guys do number 5 and 6. If you have any problems, come see me. You guys are past the point. Really, I may cut out doing some if not all of the you-dos going forward, because we're getting closer to EOC time, and circles is a really good time to kind of get you guys a little more independent in your studies instead of just copying the notes off me. Because I know a lot of you guys, I can tell how much of the videos you're watching. And anyway, so I'm going to do number 3, and actually I'm going to leave 4, 5, and 6 for you guys to get, you know, go ahead and get those yourself. If you have problems, seriously, come see me. All right, so number 3, PM is the diameter of circle R. So we're just going to go ahead and highlight that. Identify each arc as major, major arc, minor arc, semicircle, then find its measure. Okay, so the first thing they're asking is MQ. So this is the diameter. So from here to here is 180. I'm just going to say from here to here is 180 degrees. All right, so MQ is 180 minus 115. Subtract those and you get 65 degrees. So we got that part out of the way. Now, is that a minor, a major, or a semicircle? Well, it's less than 180, so it's a minor arc. Okay? See how easy that is? Okay. MNP. So we want to go to P from M, and we got to go through N. So all the way here. Well, if you notice, this is splitting in half. And half and semi, same thing. So MNP is semicircle. So there's that part. And what is semicircle, or what is a half of a circle? Half of 180? I mean, I'm sorry, half of 360. 360 being the whole circle. It's 180 degrees. All right. And lastly, I'll do this one in pink. So MNQ. And yes, I went way outside the circle, but I did it so I could show you. So we're going from here all the way around. So we have MQ. MQ was 65. I'm going to write that in here, because this is a major arc. We already know that, because it's way bigger than 180. So major. And a major arc is 360 minus one of the central angles. Well, this one's 65. That's the angle that the piece of the pie we're missing. So 360 minus 65 is 295. So that's the measure. That one's a major. That one's a semicircle. And of course, this one was minor. All right, so do number 4, number 5, number 6 on page 3. And I'll see you next time in class. Hope you have a good night.